Now we'll look at dimensional analysis with area and volume. So the first video here that I made on this, I call that linear terms, because we're talking about length of something, or the volume of something, or not the volume, but length or time or whatever. In this case, we're looking at squared units or cubic units. So area unit of conversion, convert 4 square feet to square inches. So remember that 1 foot is 12 inches. So 1 square foot is 1 foot squared is 12 inches squared. So 1 foot times 1 foot is 1 square foot. But then 12 times 12 is 144 square inches. So it's important to remember that when you're doing these kind of conversions. So a square foot is going to be 144 square inches. Now we know the area unit equivalency of 1 foot is 144 square inches. We use that to create the conversion fraction to complete the unit conversion. So 4 square feet cancel. 4 times 144 is 576 square inches. So now we can look at we're converting 4 square feet to square inches, which is what we did up here. So 4 square feet, 12 inches per 1 foot squared. So it's 4 times 12 squared. So this foot gets squared so that this here cancels with that, but it's still a squared on the 12 and a squared on the inches. Leaves that. Okay. Volume, converting 3 million cubic centimeters to cubic meters. So that 100 centimeters is 1 meter. 100 centimeters cubed is 1 meter cubed. So it's a 100 times 100 times 100 gives us that centimeter cubed. That's 1 million centimeters cubed is 1 meter cubed. So 3 million cubic centimeters times 1 meter cubed per 1 million centimeters cubed allows this to cancel here. 3 million divided by a million, is just going to be 3. Okay. So converting that kind of restates the same thing. 3 million cubic centimeters times 1 meter per 100 centimeters cubed. So that cancels here, that, and then you end up with, you're going to cube that 100 to get the 1 million, and then 1 times 1 times 1 is just 1, so you end up with 3. So converting 100 square kilometers to square miles, so we know that it's 100 kilometers squared times, I'm not sure why we don't just use the other factor here, but this is the long way to go about it. So they're doing kilometers to meters, meters to centimeters, centimeters to inches, inches to feet, and feet to miles. When I don't know why they didn't just do 100 kilometers squared times 0.62 miles over 1 kilometer squared. They probably did that because there's a lot of round off error in this process. So anyway, here's a video you can also watch. I ended up copying and pasting that into my browser window. So okay, let's talk about doing some problems now. We have length, area, and volume. We've done length. So we can think of our physical world as having 3 dimensions, length or distance in 1 dimension. Area is 2 dimensions and volume is 3 dimensions. Examples of types of units used for each of these are shown in the table of unit equivalencies. This problem, you'll determine the various dimensions for your classroom. So, I mean, you can estimate length. I'm not going to do this because I'm not in the classroom. And classrooms are going to vary, but you can think about the volume, how they're going to vary. Well, what's it going to be like length of a room? Is it going to be 30 feet? area of the floor, would that be something like, probably like 600 square feet? I don't know. And then volume. I don't really think as well in meters. I tend to go to yards. I know yards are slightly less than a meter, but that's where I go with that. So, because yards 3 feet. So, measure and record the following. So, these are things I can't really do because we don't have this specifically for whatever room you're working with. So, if you want to go ahead and play around with this, you can. So I'm not going to worry about these problems. And I guess that's it. I thought we'd have some other examples to do. Okay, well, please work on that. There are 2 sections. Let me get over to that. Hang on. Okay, so this is our dimensional analysis. This is the video I'm making right here now, so it's not done yet. But if we go back to modules, well, this has been a very full semester, hasn't it? Okay, we're down here to dimensional analysis. Where'd it go? This is the one here. Okay, so that's the paper that I'm working from. This is the page with all the videos on it. Then you have conversion, dimensional analysis, and then other dimensional analysis. So 2 assignments here to do for that. So take a look at it. I will show you something. Let's see. So I just want to show you, for example, this first problem. So given that there's 195.1 grams of platinum and 1 mole. This is a mole is a unit of measure in chemistry. How many moles of platinum are in 103.9 grams of platinum? So for that, I'll go back over to, because I have some workspace we'll go over to. So it's 103.9 grams of platinum, and we want it in terms of moles. So 1 mole is 195.1 grams of platinum. So it's 1 mole per 195.1 grams. So the grams are going to divide out. And then where to put my calculator? Here it is. And we're looking at 103.9 divided by 195.1. We end up with 0.5325. So I'll come back over to this one here. And 0.5325 is the answer. Look at that. Okay, I want to show you the other one too. And get back to this page. Wherever it went, there. Stop jumping around on me. There. Okay. So if I look at this one, I'll do a teacher preview of this one. This first problem, I don't want to be too confusing for you. So we're doing some conversion here. So we're going to convert 10 miles to kilometers. So for this first thing, you'd put in 10. And then you choose the units miles. And then 1 down here. And I think they left this one blank. So I think I do have to just pick a blank there. And then I want to convert it to kilometers. My goal is to have kilometers. So we know this is going to be kilometers in the end. And then this was supposed to be 10, not 19. Right? 10, yes. And then we do this conversion. So we want to get rid of miles. So we're going to put kilometers on top. So 1 kilometer per 0.62 miles. And then that would give me, let me just do my calculator, 10 divided by 0.62, 16.13. And let's see, I got 16.129, but it says rounded 2 places. So, hey, that's the correct answer. So that's how we do that problem. You got a few more like that down here. Okay, hope that helps, and let me know if you have questions. Thanks.